Today we will be teaching about redox. An easier way to solve redox questions is to employ the oxidation state method rather than using balanced half equations. This is because the number of electrons in each half equation can be calculated quicker using oxidation states. For example, the reduction of the manganate 7 ion to Mn2+. Instead of writing out the balanced reduction half equation to determine the number of electrons accepted, we could use the oxidation state to deduce it. Note that in the oxidation state method, electrons are used to balance the oxidation states and not the charge of the ion. To solve redox questions using oxidation states, we follow these three steps. Firstly, write oxidation state equations, meaning that the change in oxidation states of elements in the reactants and products are balanced with electrons. Do identify the known and unknown oxidation state equations as it would help in later steps. Step 2. Calculate the amount of electrons from the information given in the question. Equate the amount of electrons to the known oxidation state equation. Lastly, know that the amount of electrons accepted in the reduction equation corresponds to the amount of electrons lost in the oxidation equation. To avoid confusion, let X or N be the coefficient of the electrons in the unknown oxidation state equation. Moving on to a question example, we now aim to find the initial oxidation state of Xn+ when given the following information. Remember, the first step is to write out oxidation state equations. We know that Xn+ is oxidized to XO3-, so MnO4- will be reduced. Using information given, the amount of Xn+ is 0.05 moles and the amount of acidified KMnO4 reacted is 0.02 moles. As the ratio of KMnO4 to electrons accepted is 1:5, the amount of electrons accepted would be 0.1 moles, which is equivalent to the amount of electrons lost during oxidation. We can then see that the ratio of Xn+ to the number of electrons lost is 1:2. Since Xn+ was oxidized to a +5 oxidation state with the loss of 2 electrons, we can therefore deduce that the original oxidation state of Xn+ was +3.